Alright, in this video we will continue with our explanation on solid state as we have discussed earlier in our previous video regarding with the type of solid classifications, and this classification, as you have seen, these are based on the types of the constituent particle and on the nature. Based on the types of the constituent particles, crystalline solid are classified as covalent, ionic, metallic, and so on. And based on the nature of arrangement of the constituent particles, solid are classified as crystalline and amorphous. This is the term that we have discussed in our previous lecture, right? So today we will be continuing with the next topic. The topic that I will discuss today is for a unit cell. Unit cell. This is completely a new term which you have not heard of in your previous classes or in lower classes. This topic is used only in this unit called solid states. Right? To understand this term unit cell, it is important for us to recapitulate or to remind ourselves back with the term crystal lattice or space lattice. If you remember, when I defined you last class or in my previous video, I just said that the arrangement of the point or the constituent particle in a three-dimensional space, that are called what? That are called crystal lattice or space lattice. So for this explanation, I will assume all these points are my crystal lattice or space lattice. I will assume that each of these points are the constituent particle, and this mode of arrangement of these constituent particle are called crystal lattice. Is it okay? Now, for this definition or for this unit cell, the definition reads like this. Listen, I'm gonna explain. It reads like this: the smallest three-dimensional portion of a complete space lattice. What is it? The smallest three-dimensional portion. The smallest three-dimensional portion of a complete space lattice. The smallest three-dimensional portion of a complete space lattice, which when repeated over and again in different direction give a complete space lattice. Is known as what, or is called unit cell. I'm going to read this definition. The smallest three-dimensional portion of a complete space lattice, which when repeated over and again in different direction give a complete space lattice, is called what? Is called unit cell. Let's try to find out what is the geometry of a complete space lattice. What will be the geometry of this complete space lattice? To get the geometry, I'm gonna join all the point by a straight line, as we have studied from the characteristic of what? From the characteristic of a unit cell. I'm gonna join all these points by a straight line just to find out what is the geometry of a crystal lattice. Observe carefully. I'm gonna join this point now. I'm gonna join this point. Then I'm gonna join this point. I hope you are able to see. I'm gonna join this point as well. Or remember, this point it represents a constituent particles. I'm gonna join all these points just to see what is the geometry of a space lattice or the geometry of a complete space lattice. I'm going to join all these points. I'm going to join this point as well here. Now there are many more points which I have not joined yet. This one. I'm going to join this point as well. And yes, few more points which I have not finished to join. This point, And then what are those here? As you've seen, when I join all the point in this crystal lattice, I'm sure you've seen, when I join all the point in this crystal lattice, what did you see? I got what? I got the geometry of a crystal lattice to be what? To be a cube. So the geometry of this crystal lattice is a cube, isn't it? But if you see, if you observe carefully, you see how many cubes are there? There are 4 cubes. 1, 2, 3, 4, depending on the number of the constituent particles. Do you follow? I'm not here to explain or to draw this cube to you. I am here to explain what a unit cell. Now observe, listen carefully. I'm going to explain. I just told you the arrangement of the constituent particle in space in 3 dimension. Those are called what? Those are called space lattice. Now when we join the point, when we join all the constituent particle by a straight line, as you've seen here, it gives us what? It gives us the geometry of a crystal lattice or the geometry of a space lattice. And the smallest 3-dimensional portion, the smallest 3-dimensional portion of a complete space lattice, if you see here, the smallest 3-dimensional portion of a complete space lattice, which when repeated over and again in different direction give a complete space lattice, this is called unit cell. Now if you see, what is the smallest 3-dimensional portion of these completely space lattice? This is the smallest, which mean it is only smaller in size, but it gives us the exact geometry as the complete space lattice. If you see carefully, you will find out that this is the smallest 3-dimensional portion of this complete space lattice. Now this smallest 3-dimensional portion is called as what? Is called as unit cell, or is known as unit cell. This smallest. Here in this whole geometry, if you see, this one also becomes a unit cell, this one also becomes a unit cell, this one also becomes a unit cell if you take only a smaller portion, but the whole part of it, this will give us the geometry of the crystal lattice, right? Okay, actually if you see in this lattice that I have represent, I have drawn in such a way that all the constituent particles are present only at the corner, isn't it? But it's not possible for all the solid to have this kind of arrangement. There are some solid in which the constituent particle might not present only at the corner, but may also present in some faces. Do you follow? So based on the number of the constituent particles, these unit cells are classified into different classes. Our next topic is classification of unit cell. I'm gonna write here classification of what? Of unit cell. Classification of unit cell. These unit cells are broadly classified into 2 main categories, or into 2 main major classes. The first type is called primitive unit cell, and the second type is known as centered unit cell. I'll write here centered unit cell. Primitive unit cell and centered unit cell. So based on the number of constituent particles, based on the position of the constituent particle, these unit cells are classified into 2 types, known as primitive unit cell and a centered unit cell. Before I continue with my explanation, here I'll take one example of unit cell. In this unit cell that I drawn here, what do you see? You will see that the constituent particles are present only at the corner here, assuming that this point that I drawn here represent a unit cell. These units represent a constituent particle. Now in this unit cell that I draw, you have seen that the constituent particle are present only at the corner. It does not present in any other part of the unit cell. So these types of unit cell are known as primitive unit cell. You got that? However, if the unit cell that you draw, or if the unit cell that you get, apart from the constituent particle that are present at the corner, if they are present extra in any other phase or within the body, you got that? Such type of unit cell are known as centered unit cell. Keeping that in mind, that if the unit cell, if the constituent particle are present only at the corner of the unit cell, this type of unit cell is known as primitive unit cell. But if they are present in any other part of the phase, such a unit cell are known as centered unit cell. Alright, so I'll start first with my explanation. This one, by definition, I will define it like this: primitive unit cell. Primitive unit cell, when the constituent particle, are present, when the constituent particle are present only at the corner, when the constituent particle are present only at the corner, the type of unit cell is called what? Is called primitive unit cell. Is called primitive unit cell. If the constituent particle are present only at the corner, like in the figure which I have just shown you, this type of unit cell is called primitive unit cell. But if the constituent particle, apart from those present at the corner, also present in any phase of the unit cell, such type of unit cell are called centered unit cell. And these centered unit cell are further classified into three different classes. The first one is called a body-centered unit cell. I'll write here, body-centered unit cell. Sometimes also called as BCC, or body-centered cubic. Another type of unit cell is known as face-centered unit cell. Sometimes these are also called as FCC, face-centered cubic. And another types of unit cell are called N-centered unit cell. N-centered unit cell. N-centered unit cell. Alright, let's try to find out what type of a unit cell that are called as body-centered unit cell, what type of unit cell that we will be calling face center, and so on. Right? Okay, I'll take this example here. I'll draw one unit cell. In this unit cell, you will see that there are 8 constituent particles. 8 constituent particles here. All these things that are present at the corner, these represent a constituent particle. So 1, 2, 3, 4, 5, 6, 7, 8. You got that? Alright. If the unit cell that I have contain a constituent particle only at the corner, then such type of unit cell, we will call it a primitive unit cell. But if the unit cell that I have, apart from the constituent particle that are present at the corner, it also contains one constituent particle within the body. Remember, not on this face, not on that face, not on this face, nor this face. Actually, it's present inside that cube. within the body, apart from the constituent particle that are present at the corner. If it contains one constituent particle within the body, that type of a unit cell is known as body-centered cubic or body-centered unit cell. You got that? Keeping that in mind that the shape of this unit cell is a cube, which means that there are 6 faces. 1 that side, 1 this side, 1 this side, 1 this side, 4. 1 up, 1 below, 6. Isn't it? 6 faces. Here, the constituent particle that I show, it does not contain on any face, actually is contained within the body. So we call it body-centered cubic. Let's try to find out what type of unit cell do we call a face-centered unit cell or a face-centered cubic. We'll try to find out this type of unit cell. You got that? Alright. Let's go on with it. Now, I will assume that this one is my unit cell. Forget about this point first. This one is my unit cell. And in this unit cell, anyway, let me draw a new one instead. Here, this one is my unit cell. In this unit cell, what do you see? It contains 8 constituent particles at the corner. 1, 2, 3, 4, 5, 6, 7, 8. Alright? Now, apart from these 8 constituent particles that are present at the corner, if it contains one constituent particle at the center of each faces, say this face, there is one extra constituent particle. This face, there is one extra constituent particle. The face above, this one, face above, there is one extra constituent particle, and this face below, there is one extra constituent particle. That face which is behind, I'll represent here, one extra constituent particle, and face, this one, the face which is towards you, towards the viewer, I'll put here one extra constituent particle. Now what do you see here in this type of unit cell? Apart from the constituent particles that are present at the corner, there are also constituent particles at the center of each face. Such type of unit cell are known as face center cubic or face center unit cell. So we have studied the second type of unit cell. I'm gonna explain to you the third type of unit cell, that is called n-centered unit cell. Okay, n-centered unit cell. What kind of unit cell do we call an n-centered unit cell? All right. Now, let me try to draw this unit cell here. If you observe carefully, you will find out that there are 2 unit cells here. This one, isn't it? And this one, 2 unit cells. The total number of constituent particles here will be how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here altogether, how many constituent particles are there? There are 12 constituent particles, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But they are present only at the corner. So again, this type of unit cell we will call the primitive unit cell, isn't it? But if it contains one constituent particle at the center of the face, which is joining the 2 unit cell, this type of unit cell is known as n-centered unit cell. Why do we call it n-centered unit cell? Because at the end of this phase, which is joining the 2 unit cell, it contains one particle at the face. So this type of unit cell is known as n-centered unit cell. That will be all with the types of unit cell. In my next explanation, I will be explaining about the number of atoms in a unit cell.